Hello everybody and welcome to Industrial Automation, It Doesn't Have To. In case you're new to the program, I'm Brandon Ellis. I'm your host and also the owner of elliTek. As we jump into the episode for today, I want to ask that you hit that follow button and subscribe button based upon the platform that you're listening on. And if you're listening specifically on Apple Podcasts and Spotify and you enjoy what you hear today, leave us a 5-star rating and review. We sure would appreciate it. Now that we've got the marketing out of the way, I just want to say thanks for tuning in. So, let's get started. Hey, Beth.
Hey, Brandon.
How are you?
I'm doing good. How are you?
I forgot to give you your special music.
Oh.
Ladies and gentlemen, Beth Elliott.
That's it.
That's it. You like that?
Gonna have that coming when I go into every room.
It's either that or Beth Elliott.
I don't know. I guess it depends on the situation.
Yeah, there you go. So,
what are we going to talk about today?
we haven't really got a title. Sorry, people on video see me scratch my nose out an itch. We haven't got an official title.
No.
So I wanted to make one up.
Please.
So industrial automation, it doesn't have to inflate.
Inflate.
Yeah. So we're talking about inflation.
Mm-hmm.
And so basically with prices rising across, really across the board in the U.S. and just the U.S. is experiencing historically high inflation. What can we do? What can companies, manufacturers do, specifically management do to battle that? And so battling inflation by increasing our ROI. Well, when I say increasing our ROI, I'm not talking about making it a longer return on investment. I'm talking about making it a shorter return on investment by getting more bang for your buck. And so how you can do that is spread it out across multiple things, multiple processes. So how in the world would you do that? Well, we're going to do it mechanically.
All right. Nice.
And so that's a little bit different viewpoint. So how in the world, Brandon, can you say you're going to do a mechanical solution to spread a very much a financing or an accounting based calculation, to spread that out so that it actually increases the bang for the buck, so thereby bettering our return on investment. And we'll have a way to talk about that.
All right. But before we get into that, what have we been up to? Because it's been a few weeks, hasn't it?
It has been a few weeks. So I will say this. For those of you who are listening, first of all, thank you very much.
Yes, thank you.
For all the downloads, the streams, the comments, the thumbs ups, the subscribers, the reviewers, all the things. Thank you for doing that. We have crested over 3,500 downloads since beginning.
Thank you, guys.
This podcast. And so, thank you very much for that. But what we're doing as part of season 4 is the podcast has been doing fantastically well. And as a result, Beth and I have been getting worn out. and so we used to do every other Tuesday, every 2 weeks. And we did that through 3 seasons, and that was quite a lot of episodes. So the amount of work that has come to be what is now, and of course most of that work, I'm going to just call it what it is on Beth's shoulders. But it has become a large amount of work. And so what we're going to do to battle that is we've decided to cut it in half. And so approximately. So we're going to have new episodes approximately every 4 weeks, and that may adjust a little bit based upon how things are going.
Yeah, and schedules,
well, that's what I mean, schedules, not how things are going as far as the success. I mean, goodness gracious, 3,500 downloads. That's
good.
Pretty awesome. But the schedules of things going on, and just life's ins and outs. And so we want to make sure that you all were cool with that. And everybody we've talked to said, hey, that makes perfect sense. So that's what we're going to do. So it has been a couple of weeks, 4 or 5 weeks, something like that, 3 or 4 weeks since our last episode. And so we're talking about what's up. Well, that episode's up. We want to talk about that a little bit. I'm going to quiz you a little bit on it.
Uh-oh.
So that episode was about confusing Fieldbus protocols with standard networking terminology. But we'll circle back to that. So what's been going on? 2022 has kicked off pretty interestingly. Now, it's an extension of 2021. A lot of people are pushing, because of the ongoing labor shortage, a lot of manufacturers have been pushing to automate processes. And pre-COVID, we would automate processes to try to reduce labor, reduce bottom line. But post-COVID, that's totally different. We're trying to create labor. And so there's been a push to do that. But there's also this thing going on that's still raging on called a supply chain crisis. And there's not a single industry that hasn't been touched by that, hasn't been affected by it. Whether you're going to the grocery store or whether you're, a U.S. automaker trying to make vehicles, that need chips. Everybody is being touched by this. Mm-hmm. And then this inflation thing just is salt in the wound. So what we've been doing Q1 of 2022 is more pushes to automate. And a lot of that is robotically. And for us specifically, we're looking at and helping customers with a lot of industrial robot applications. A lot of people are wanting to automate using the articulated arm type robot. That's one of our podcasts. If you don't know what that is, we can take you through that. I don't remember which one that is. Put that in the show notes. An articulated arm robot is a 5 or a 6 axis robot. It's kind of like the human arm and hand, wrist, that kind of thing. But there's collaborative robots, which mean that you can have a bit more safety, but the most important thing is direct teach, which makes it easier to program and to recover and things of that nature. And so we've had quite a few successes that are some of the extensions of last year, and some are new opportunities using our Hanwha robotic line. And so that's one of the big things that's been going on. The other thing, I mentioned that the supply chain crisis rages on. We actually have gained a lot of new customers.
Yeah.
For the lines we represent. Usually we don't get into. We talk about the lines we represent from an experience standpoint, but we actually had a customer that was having trouble getting a servo motor and drive because of lead times associated with the company the brand that their plant specs. Uh-huh. Very popular brand. And the PLC is also very popular brand. That's Rockwell Automation on the PLC. And they couldn't get the servo motors that they needed in drives in a timely fashion. And so they contacted us and said, what can you do here? And we were able to cross the things over from their original design, from the original servo manufacturer, which we didn't represent, to Yaskawa. Okay. And Yaskawa makes, of course, rotary servo motors. They make linear servo motors, but this was a rotary servo motor application. And we were able to get them. We had to make a couple of tweaks on cables and stuff like that. Mainly, if this length was out, we'd change the length. But we were able to get them that product in under a week.
That's great.
It's very great. It's unusual by today's standards, current standards. And so being able to have a win like that, really, we needed that. I love to hear those types of wins. And you just haven't unfortunately been able to hear that much since really mid part of 2021. Mm-hmm. Now, that's not true with all of our lines. We have some lines that are suffering just like everybody else. Yeah. And even within Yaskawa, they have a couple of specific lines, specific products that may not be on the shelf. Mm-hmm. But they've done a really good job at managing that. So that's kind of been some of the things that's up.
All right.
Yeah. The quiz.
Uh-oh.
So I got my quiz music here.
Okay, let's go.
So in the last episode, we were talking about a comparison between the term TCP/IP and what most soundy likey the Fieldbus protocol name that most resembles the term TCP/IP. You ready?
Is it Ethernet IP?
Ethernet IP. So why are we picking on Ethernet IP? We're not picking on Ethernet IP. Ethernet IP is a very popular Fieldbus protocol. And it sounds a lot like if I say Ethernet IP, and if I say in another sentence right after that TCP/IP.
Yeah.
It sounds very similar. And so it is often confused by those that are selling the product, those that are specifying the product, those that are, in charge of selecting the products. And so if you're at the C level, this is very frustrating for you. If you're engineering manager, that's what I mean when I say C level. If you're CEO, management, CFO, COO, head of accounting, having a project, having a capital appropriation that has a budget, that has an ROI, those boxes are checked, and all of a sudden you find out the stuff we got won't talk to the other stuff we've got.
Oh.
And we're going to have to do away with that stuff and buy more stuff. That blows budgets, and that's not what anybody wants.
It's not any day.
Especially if you're at the C level. And so Ethernet IP and TCP IP sound very similar. Other Fieldbus protocols that are not as similar, still popular, but don't sound similar. EtherCAT, Modbus TCP, and the other one comes to mind is Profinet. Those sound significantly different than TCP/IP, and so the things that I've seen across my storied career is seeing that someone ends up with a product that has an RJ45 port where you would plug just like you plug into your computer or into the wall for a wired network connection. And we're talking specifically about networked-based or Ethernet-based protocols, Fieldbus protocols. If you have a product that has that plug in it, and it says in the manual by the manufacturer that it communicates via TCP/IP, that does not mean that it will communicate Ethernet IP protocol, or can be an Ethernet IP node on a network just because it has a TCP/IP port.
That's right.
And those two things get confused. So let's lay it out real quickly.
Okay.
Second question.
Okay.
What was the analogy I used to denote TCP, the TCP portion of TCP/IP?
It would be a train.
A train.
Because it's transmission control protocol.
That's right.
It's the train and the engine and all that.
And the cars.
Yes.
Yes, and even the tracks. So it's transmission. Transmission, that's the main thing. So when we're doing transmission, we're transfer. So it's a means of transport. So the 30,000-foot view of that is it's the train and everything that the train needs, the tracks, everything to make this work. What is what is the analogy of what goes in the cars?
Oh, it's the protocol that goes in the car.
The protocol.
Which would be Ethernet IP, right?
In this scenario, if we're talking about Ethernet IP, that is the protocol. That's the language that takes place. And so TCP/IP is simply the means of transporting whatever language, protocol and language, you can use those two interchangeably, whatever language you're talking. So just because you support TCP/IP does not necessarily mean the cars are filled with that language, and that language is Ethernet IP in this example, or EtherCAT, or Profinet, and those others, the Modbus TCP, the other ones I mentioned. Now we're talking about network protocols. There are serial protocols that we talk about in the episode. If you want to learn about those, it's called Industrial Automation. It doesn't have to. Number 33. Because we didn't come up with a title. It's the previous one. It's episode 1 of season 4. You can check that out. But those things are what we talked about there. The other thing is the IP portion.
Yeah.
So TCP, IP, what the heck does that mean, Brandon? Why does it have a slash in front of it? Because it's kind of separate. But what is the scenario that I used, or the what's it called?
Your analogy?
The analogy. Thank you.
So it's the tracks. Oh, I'm sorry.
No, it's not the tracks.
Okay. Wait, IP now. You got to say this question again, please.
What was the analogy that I used that described what IP was for?
Oh, the tracks. I'm sorry.
Not the tracks.
That's the destination.
The destination.
But because the tracks are the TCP.
Tracks are part of the TCP part, the transfer part. It makes the train go. The IP is the
destination, is it not?
It's the destination, but you said tracks.
Oh, because it's TCP IP is the tracks.
TCP. Okay, all right. So we're getting off the weeds here. So my analogy, and this is Brandology. My analogy is TCP defines the train, the tracks, the cars, everything that needs to go. Tracks can go anywhere. So you need a destination. You need a manifest. And so the manifest is the IP portion.
Okay.
Which is basically the internet protocol. But if you have an IP address, your computer right now, your phone, because it's on a network, whether it's cellular or whatever, well, especially if it's on a Wi-Fi network, your phone has an IP address. You're listening to this podcast through a streaming service, and it has an IP address. And so when you type in www.elliTek.com in your favorite browser, it's actually going to go to what's called a DNS, a domain name server, and that just says, hey, we're looking for elliTek.com. That doesn't make sense because everything needs to have an IP address for that destination. It will say, okay, let me look through my little name server here, and it goes down and it says, oh, here it is. elliTek.com equates to this IP address, and it'll hand that out. This happens without you knowing it.
Yeah, it's quick.
And now you've got your destination, and so you go out in the connection. It's not really a connection, but it's a web server. But it still connects to the web server. It gets the information and serves it up. And so that's what the IP scenario is that it's the destination. But all of this means is TCP/IP sounds a lot like Ethernet IP. Don't get them mixed up because it won't work.
That's right.
Yeah. So that was all. That was that.
So we need to talk about how people can expand their ROI mechanically.
Mechanically.
Yes.
So how do you do this? Well, we were talking a bit about the Hanwha robots, but collaborative robots in general. And you can do this with my microphone here. Sorry, it's going to make noise. You can do this with both industrial or collaborative robots. But a product that we represent here in the United States is called Smartshift Robotics. Smartshift Robotics. And so Smartshift does some really cool things. And you've got some video for us.
Yes.
So one of the things is, before you show the video.
Oh, my bad.
Yeah. Before you show the video. How are we going to increase the ROI? Actually, show the video.
Okay.
I'll change up how I'm going to present this. So we're looking at the video, and for those of you not watching the video, I'll explain this. So we're looking at a robot, not a brand we represent, but still one we work with, and a gentleman's holding onto the base. He's twisted the bottom. He's loosened the screw, twisted the bottom. He's bringing it over. Part of the two-piece. It's a two-piece tool. One's connected to the base of the robot. The other one's connected to the base where it's being locked down, the base of the table or the frame. He slides it in. It's a dovetail slide design. Twist it around. It locks into place, and then he screws the screw in to secure it. So why is that a big deal, Brandon? Well, what just happened was, in the video, the gentleman went to the robot at one location and simply in just a few seconds loosened a thumb wheel screw, twisted the base around to unlock it, slid out from a dovetail slide design, which dovetail, when you hear dovetail, you should think accuracy, repeatability, carried it to another base that was already in place, slid the dovetail back, slid onto the dovetail receiver on that side, twisted the lock in to lock it down, and then screwed in the thumb wheel to secure it. So now that robot is referenced, has established the point of reference that it had when it was in that position before and was programmed, the points and things of that nature, we call those datum points. All the machine references, the datums, are back to where they were. Remember, accuracy, repeatability. So suddenly, the cost of that robot and the ROI calculation doesn't have to be just the process, the first location that it was applied to. If we have a process on first shift and we're having a hard time justifying it through the ROI calculation to put a robot on that process, because that process only runs while we talked about how to the 4 ways to decide if it's a perfect application for automating with a robot. Mm-hmm. Do you remember those?
Brandon's Brandology for the 4 reasons to automate.
It's not the 4 reasons to automate. The 4 reasons to put a robot, if it's a good application for a robot.
That one's easy. So you got a mitten on.
A mitten on your hand.
Blindfolded.
Blindfold over your eyes.
Standing in one spot.
And
just, what was the other one?
One arm behind your back.
That's right, because you just have one hand.
That's right. And so feet glued to the floor, blindfold on your over your eyes, a mitten on the end of your hand, and one arm behind your back. Not the mitten arm, the other arm.
Yeah.
If an operator can be in that configuration and still perform the task, it is a perfect opportunity to automate. As far as from the technical standpoint, it should be a perfect opportunity to automate, assuming payloads and speeds and things of that nature come into play. But if you're trying to, if that process only is a first shift process, so if you run multiple shifts and we really only run that on first shift or occasionally, then we have a hard time justifying the return on investment of all the things that go into play to adding even a collaborative robot or industrial robot, which honestly, industrial robots cost less sometimes than collaborative robots. So even with the reduced cost on the robot, whichever way you're going, it can be difficult to justify that return on investment because we just don't run it enough.
Oh.
But if suddenly I can take that same robot and I can put it on this application, especially in the manufacturing industry, a lot of times manufacturers have what's called service parts. Service parts are usually parts that they made a long time ago, and they still get requests for them, either for repair or aftermarket or something like that. But they're not coming in the volumes that they had before, so they can't they can't devote an entire shift for it.
Small batch
runs.
Okay.
And so to be able, that's a perfect example because it's difficult to say, okay, we run these service parts, we have to put a person on there. But we don't run that often enough to justify automating the process. But man, we would like to. Well, now all of a sudden you can potentially stack up some service parts, or you can say, okay, well, we need this robot running this process on first shift, but we want to move it. We can justify it if we spread the cost across multiple processes, and we can run those on different shifts or just at different times or different rates. Now, unbolting a robot and rebolting a robot is usually a pretty involved task.
How long does it usually take?
Well, it's according to the size of the robot.
Yeah, okay.
But with a smaller collaborative robot, like we were showing in the video, we can certainly, especially with the addition of the Smartshift quick change bases, now all of a sudden you can move it very quickly. In fact, with collaborative robots, the majority of the ones I'm familiar with, and certainly this is the case with Hanwha, we have two things: quick change cables right at the base of the robot.
Oh, so you
just twist and unlock the cables. And then the controller actually has a carry handle on it, but it's 110 volts. It's very portable, or it can be made onto a little cart that moves along with it. And so you can make this very quick to quickly change in, say, less than 30 minutes to take a robot from one process, move it over, and put it on another process. And usually, with most machines, a 30-minute changeover is not bad. 15 minutes even better, and I think you could probably do it in 15 minutes.
Well, that dude did it.
He did it in less than 2 or 3. Yeah. But what you're able to do then is actually use that robot in multiple processes, which now expands the impact.
So you could spread that cost out across different lines.
You're amortizing the cost across multiple processes. And so now your ROI, and you haven't done anything electrical. You've done it all mechanically. And the Dovetail slide, the difficulty is how do I get it back into the same place? So all I have to do is select a program and click start on that program, and it picks up where it left off when we were at this position, and it's not changed from having been moved. And that Dovetail slide gives us the accuracy and the ease of movement and implementing that that allows you to do that.
Is Smartshift the only one that has that Dovetail system, or is that what makes them unique?
From my perspective, they're the only ones that have the Dovetail system on the robot bases.
Okay.
Quick change base. But there's another aspect. So you can say, okay, Brandon, fine. I can take the base of the robot and move it from one place to the other. But unless my tooling is exactly the same, I've got to do a tool change.
Yeah.
There's other companies that make quick change tooling, quick change tool sets and things of that nature. They can be very expensive.
Okay.
Some of them are pneumatic and things of that nature. They're meant for automatic tool changes that are taking place within an industrial robot cell that's doing multiple processes. But in this case, where we're picking this up and moving it over, Smartshift has a very mechanical. You can either do it. It's a mechanical version. They have two flavors. It's really the same quick change pieces that go on the robot. You have a piece that mounts to the robot, the end of the robot. Then you have a piece that mounts to your actual tooling. Those two go together, similar dovetail type slide. But you can do a manual release just by hand, or they have a base that you can incorporate to where you can do quick tool changes. Now, again, the quick tool change would come into a place where the robot usually is staying put. It's just changing tools on its own within a typical process. With my scenario here, we're talking about moving the robot physically to other processes. And so in those cases, the manual switch is probably the best.
Oh.
You got a video on that?
Yes, I do.
So those watching the video, let's give it a look-see here. So again, we've got the piece that fits on the robot, and then we have the piece that fits on the tooling. And it just slides together. It's kind of difficult to see.
That looked really fast, didn't it?
Because it was so fast. Restart that.
Okay.
So for the people watching, the tool is mounted on the base. All he's going to do is push a button on the back, and he holds the button on the other side, and as he slides the dovetail in, it snap locks. And it's totally mechanical. That is a very easy quick change.
That was so fast, I didn't catch it.
So let's leave that up right now so we can look at it.
Okay.
So you also see that there's some electrical lines coming down. There's a pneumatic line coming down. That's just passing through from the top of the robot. It's not necessary for the tool change function itself. It's totally mechanical, the tool change. That's just, in this case, they have sensors, so there's an electrical pass-through that's taking place. So your tooling can already be set up and have the sensors connected to it and the airlines connected to it. And then when you snap it on, it makes those connections for you, those unions. But that it's not necessary to control the tool change. It's a mechanical push of the button, and you can kind of see. Can you back it up just a minute, just a little bit?
Let's see if we can go like
to where his hands are out there as he's placing it, and just pause it there. You can see that he's actually squeezing the lock with his index finger from the backside. Go back one more. So, yeah, he's got a hold of the lock with his index finger there.
Okay.
So go ahead and start it from there.
I'll go real slow.
Click play.
I was just gonna go real slow.
You're doing slow motion.
Yeah, okay, sorry. I'll speed it up.
Yeah. So did you see him?
Oh goodness, it was so fast.
It is fast. Yeah. Start it again from back it up there. This is like replay on.
I know. Wait.
Sports Center or something. I can't draw though. Go ahead. So click. He just clicks it right in, and so it's a mechanical spring actuated deal. It can take multiple thousands and thousands and millions of cycles in and out. And so it's really simple. And you know how I like simple.
Yes.
Simple also means, because it's mechanical, it also means inexpensive, relatively speaking. And so some of the tool changers I mentioned to you earlier are pneumatic changers and things of that nature. They're pneumatically controlled, really meant for more automatic changing. Smartshift is mechanical, and so it is, relative to those, less expensive. But so that's how we would increase or decrease our ROI, increase our profitability overall, and make a good case for automating a process. Even if it's a single process that doesn't make sense, if I can get multiple processes that can run concurrently, not concurrently, can run consecutively. Yeah. So we'll do this for so long, and then we pick it up, move it over here, run a shift or something on this one for so long, and so on and so forth. And we can amortize the cost of the robot across the multiple processes. And so suddenly it opens up the possibilities.
Did you want to do a show with just the changing tool itself?
Yeah. So the changing base, again, so that's how we would, what we've seen so far.
Okay.
The quick change tooling on the end, mechanical change that can be changed by hand, and then, of course, the Dovetail style quick change robot base that allows you to actually physically move the robot. That's how we increase the ROI. But we're talking about Smartshift, and I want you to see this. They have another, again, this is all mechanical. You'll see a quick change tool here if you're looking at the video, and it utilizes the same mechanical stuff. It's just that the holders actuate what the human was doing.
Yep.
And so they slide in, they slide out. So one takes it off, one puts it back on. And so you can see that with that little tabletop quick change, suddenly there's no wires going to that.
No.
It's not electrically controlled in any way. It's purely mechanical, and it's just a really, really elegant design. Really simple design.
We're going to play that video again. I'll have links in the show notes to these as well. But that's pretty cool. So what instances do you see that happening if they're doing if that robot's having to do two different tasks?
Yeah.
Do one and then the other with different
tool sets.
Okay,
yeah. So your end of arm tooling needs to change. So maybe you've got one set of grippers for one size of a part, and then you change over to a different part. Again, the automatic stuff in my mind would usually be for leave the robot alone in one spot. We're just going to be running different parts through, or one part, but we have to do different operations.
Okay.
So we're talking about if you're going to change a gripper or something like that for picking up different things. But also, what if you're sanding? What if you're polishing? Well, you don't polish with a sander.
No.
And you don't sand with a polishing head. What if you're cutting? You might do ultrasonic cutter. So we may have an ultrasonic cutter head on one of those and pick it up and move it over and do some stuff. So our vision system or something like that. Now, granted, this isn't all mechanical. It's got some pass-through. If we're doing vision systems and that kind of thing, tool changes with vision, because we have communications and that kind of stuff, gets a little interesting. So that might be a little above what we would be practical for this. But those types of situations where you have a single robot cell, but it needs to do multiple operations or pick up multiple parts or have a changeover where this one's a bigger diameter than that one, but the process is still the same, those are perfect examples of why you would want to do a quick change.
And I've got one more video of how precise they are.
The changes.
Yeah.
So this would be the same whether you're using the automatic or not. They're using the automatic on the tool change here. But again, the automatic is just allowing us to make changes with the same tooling that we called the manual change. And so if you snap this on by hand, now it's looking at, so it picked it up. Picked it up, moved over to a datum surface. It's got a dial indicator, and it's pressing down to a position. You see the needle come in very accurately. It lets go of it, moves over, comes back, picks it back up, and does the same test. It's doing it both vertically and side to side, and you can see it's coming back with that repeatability.
It's right on spot.
Why is that? That's because of that dovetail slide design.
Okay, nice.
That's what I mean. There's not wiggle. When it drops it off and picks it back up, it's not. If you unbolted and rebolted, you could have some changes. And we're talking potentially minute, but if you need accuracy, you're going to get it with this. And that's the cool thing about Smartshift Robotics.
That's nice.
So hats off to them. Good job, guys. I always hit that. Let's say it again. Hats off to them. Good job, guys. And that's applause. That's not rain. So, Smartshift Robotics. Yeah, that's a company that I really have been impressed with, as far as just taking something and keeping it mechanical, keeping it simple, keeping it accurate makes folks like myself see all kinds of advantages. Yeah. And so, the fact is, it's got a huge advantage to the accounting department.
That's true. Yep.
So that's what we've got for today. We need to just quickly review. So if you're checking out our podcast, you can check it out on any of the podcast streaming apps out there. For most of them, just search on elliTek and you'll see industrial automation. It doesn't have to come up. So give that a try. If you're on a new streaming app or you want to find more episodes, you can see those there. Also, you can check us out on our Facebook page. Check us out on LinkedIn, Twitter, Instagram, our YouTube channel, and what am I missing? You can rate us on Spotify.
And Apple Podcasts.
Mm-hmm. So we ask that if you like what you hear, give us the biggest rating that you can possibly come up with. That helps us as far as promotion, but certainly I want to thank you guys because you are doing your part.
Yes.
We are seeing a lot of success, and a lot of people are getting a lot of good feedback. So I hope you've enjoyed what you've heard today.
That's right.
We'll be back with another one in a few weeks.
3 to 4 weeks.
Yeah. And so, Beth?
Yes, Brandon.
Have a fantastic day.
You too. Thank you for your expertise as always.
All right. We'll see you guys. Hey guys, thanks for checking out today's episode of Industrial Automation It Doesn't Have To. I hope you enjoyed it. If so, make sure you give us a rating that's pretty doggone high, and do that everywhere you listen, including Spotify and Apple Podcasts. We'd really appreciate it. Also, don't forget about our website. That's www.ellitek.com. That's ELLITEK.com. If you want to reach out to us there, you can fill out our contact form. We'd appreciate it. Also, you can email us at info@ellitek.com. And certainly for those of you that still like to dial the phone, give us a call, 865-409-1555. We'd love to hear from you.